Hi there. So we have learned some new things here. So we have added, subtracted, multiplied, and divided functions, and we saw that we get new functions, and we can find the domain by finding the domain of those the given two functions and taking their intersection. Another way of combining function is what we call composition of function. So how do we compose functions, or what does this mean? So we define it like this, that given two functions f and g, the composite function. So the name of this new function is composite function, and this is the way we write it. So it is f and then a small circle and then g. So it is not fog, by the way. It is f composed with g. So, and we also call it the composition of f and g. Sometimes it is said f composed with g, or just the composite function of f and g, because we can also have g composed with f. So g, like g composed with f, we can also have this. So whichever is coming first, we just say it in that order. And now we define it like this. They say f composed with g of x is equal to f of g of x. Means remember, x is the independent variable or input, and f is the function. So when in other words, when x is input in the function machine, whose name is f, it spits out f of x as the output. So in our function f composed with g, this is how it goes. The picture, this picture around here, can make you help you understand. So because we are now starting with the g function, so you can think of the x goes into g. X is the input, it goes into the g function, it spits out g of x. Now g of x goes to another function, so it means g of x is in the domain of this f function, and now it will spit out f of g of x. So this is how the process goes. So how do we now find these functions, and how do we evaluate, and also how do we find the domain of these functions? Now notice here that x goes into the function g, but x can go into the function g if x is in the domain of g. So, but now g of x is going to go into the f of g f function. So this means g of x must be in the domain of f. Now it's hard to look at it that way. So what do we do to find the domain of the two functions? We look at the function g, which is the, we also call it the inner function, and this f has the outer function. So we find the function f of g of x, and then we look at the domain of g of x and look at the what is if there is anything else extra which is not fitting in the this composition of function that we have found. Then that if there is something extra, we have to do that. Let's look at an example, which is example 2 here. So our f function is 3 minus x squared, and our g function is here 4x minus 2 over x plus 1. So evaluate these quantities. So first, without even finding the composite function, we can actually evaluate it by using just a definition. So this quantity will be equal to f of g of negative 2. So what is g of negative 2? We plug it in g, so we get negative 8 minus 2 over negative 2 plus 1. So we get negative 10 over negative 1, which is 10. So this is just, remember, g of negative 2. Now I have to find f of 10, which will be, we'll plug in the f function. So 3 minus 10 square, which is 100. So answer will be negative 97. So that is the value of the composite function at negative 2. On this side here, it says find this value, g composed with f. So according to the definition, this will be g of f of x. Okay. So now f of but x is 5, so it will be g of f of 5. So what is f of 5? F of 5 equals 3 minus 25 or negative 22. So I have now to find g of negative 22. So this will give me 4 into 22 is 88. So I get negative 88 minus 2. And at the bottom, negative 22 plus 1, which is equal to negative 90 over negative 21. 3 goes into both, negative becomes positive, so we have 30 over 7. That is the value of that quantity. Now we have to actually find the function and then their domain. So when we say f composed with g of x, like we just did with the numbers, we can write it as f of g of x, which is equal to what we do now. In the function, wherever there is x, it is replaced by the function g of x. So we will have 3 minus, so in place of x, I have to write the function g. So I have 4x minus 2 over x plus 1 whole squared. Now I can simplify 3 minus, so I'm getting 4x minus 2 whole squared divided by x plus 1 whole squared. So 3 times, now note here, sorry, 3 minus, we can pull out actually a 2 from the numerator if you want to. If you don't, it's okay. How will you find this whole square? Well, you can go on a side or on a separate paper and you can write 2 copies of 4x minus 2 and multiply them out. I'm going to do it directly. So applying the formula. So I get 3 minus, and on the top here, 16x squared minus 16x plus 4. That's the top, and bottom is x squared plus 2x plus 1. Now taking the common denominator, because this is 1, so common denominator is x squared plus 2x plus 1. And on the top here I had 3, so 3 gets multiplied with this quantity. So you get 3x squared plus 6x plus 3, and then minus this whole quantity up here, minus 16x squared plus 16x minus 4, which is going to give me, so the bottom is Same, if you want to go back and write it x plus 1 whole square, you may. And then the top will be, so now we can combine like terms. So negative 16 x squared and 3x squared plus 3x squared will give us negative 13x squared. Now the term 6x plus 6x and plus 16x will give me plus 22x. And then we have 4, negative 4 and plus 3. So I get negative 1. And I don't think we can factor it. So this will be your answer. Now what about the domain? We will come back in first. Let's find this other function. So this is saying g of f of x. So which means in the function g, wherever you have x, it will be replaced by the function f of x. So some people like to write this step. If you want to, not necessary, but if it helps. So, but f of x is what? 3 minus x square minus 2, and the bottom is 3 minus x square plus 1. Simplify. The top is going to give me 12 minus 4x square minus 2 whole divided by 4 minus x square. Simplify. We get 10 minus 4x squared over 4 minus x squared. So this will be the function. What about the domain? For the domain, here in this one, first one, what is the domain of G? The domain of G is negative infinity to negative 1 union negative 1 to negative to positive infinity. Okay. So now if we look at this final result that we got, what is the domain of this one? It is the same as that. So the domain of the f composed with G is also the same. When we come to the next function, this is G composed with f. So f is the inner function. So what is the domain of f? So the domain of f is all real numbers because it's a polynomial. But here we see in the final result, what is the domain here? The domain is everything but not negative 2 and 2. So negative infinity to negative 2 union negative 2 to 2 union 2 to infinity. Now if you combine these domain or try to find the intersection of the two domains, what will be the answer? Domain of G O F. G composed with F is this domain. So this is how we find the domains. Okay. So the next example I'll do in the next video.